Let's evaluate the integral of product of cos inverse of x and x dx. You can see that we got product of two functions, cos inverse of x and x. So we will apply product rule. Product rule says integral of u times v dx, integral of product of u and v dx equal to first function, that is just u, and then integral of v dx, product of u and integral of v dx, minus integral of derivative of first function, that is u dash, that is derivative of u with respect to x, to be multiplied with integral of v dx, and then this product has to be integrated once again. That is all about product rule. Obviously, the question is, which one should I take to be first function? Should I take cos inverse of x to be first function or x to be first function? That matters. But we have got a standard idea that something called ILATE rule. ILATE. I stand for inverse function. Since inverse function occur first, so we will evaluate the inverse function to be the first function. We will evaluate the integral using inverse function to be the first function. So let's start. Integral of cos inverse of x, that's the first function, times x dx equal to first function, that's cos inverse of x. First function u is cos inverse of x, first function, times integral of second function, integral of v, that's just integral of x dx, minus integral of derivative of first function, so d dx of cos inverse of x, to be multiplied with integral of second function, that is integral of x dx, and then this product has to be integrated once again. That is it. Okay. The first function cos inverse of x we write as it is, we simply copy as it is. How about derivative of cos inverse of x? Derivative of cos inverse of x is minus 1 by root over 1 minus x square. How about integral of x? Integral of x to the power 1 is x to the power 1 plus 1 by 1 plus 1. Integral of x to the power n is x to the power n plus 1 by n plus 1, minus integral of derivative first function, we already did it. Integral of x is x to the power 1 plus 1 by 1 plus 1, that is x square by 2 dx as it is. We can cancel negative out and we can write this as x square by 2 times cos inverse of x. Negative of negative is positive. I can take half, that's just a constant outside of the integration, and we got x square divided by root over 1 minus x square dx. Somehow I want to simplify this expression. I can do it by writing this as minus x square. Oh, I need to write minus once again, and then adding 1 and then subtracting 1. What's the advantage? First of all, make sure that equality is maintained. 1 and 1 will get cancelled, minus and minus will get cancelled, so x square as it is, that's correct. And then let's simplify it out. X square by 2 cos inverse of x, that we can copy as it is, plus 1 by 2 integral of minus of 1 minus x square divided by root over 1 minus x square dx. Minus of minus is plus, so plus half integral of 1 by root over 1 minus x square dx. Okay, x square by 2 we write as it is, cos inverse of x we write as it is, root and x we can cancel. We can say that u by root u is simply equal to root u. Hey, too simple, right? Yes. So minus half integral of root over 1 minus x squared dx. How about this one? This one, if you integrate it, we simply get sine inverse of x. X squared by 2 cos inverse of x minus half. Now this is an standard integral of the type root over a square minus x squared dx, that is simply equal to a square by 2, so 1 by 2 root over a square minus x square, so 1 minus x square plus a square by 2 sine inverse of x by a is 1 plus 1 by 2 sine inverse of x we copy as it is plus 1 by 2 sine inverse of x. Of course, we got indefinite integral, so there is some constant of integration. Can we simplify it out? Yes, we can simplify it a bit. And write this integral is x squared by 2 cos inverse of x, and then you got minus 1/4 sine inverse of x plus half sine inverse of x. Half minus 1/4 is just 1/4, so plus 1/4 sine inverse of x, sine inverse of x, and then you got minus 1 by 4 minus 1 by 4 root over 1 minus x square plus some constant of integration.